Hi, I'm giving solution for the integration by parts and integration by substitution in this video. So the question C in the exam is integration of 2 um, and we have an integration sign after that. It's x plus 1 in bracket into x square plus 2x. So there are two ways to do that. Either you can break the brackets down and get 4 terms and integrate them, or you can use integration by substitution. So in integration by substitution, you are going to put the second term as u, and you'll do that because the first term looks like the integration of the second term, so that gives me a hint to think on those lines. So I'll put u of x is x square plus 2x. When I integrate it, I'll get 2 into x plus 1, and du is equal to 2 into x plus 1 by dx, and this also helps me cancel out this 2, so this 2 is intentionally kept so that I get a sweet answer. Now dx is du by 2 into x plus 1, and now modifying the main equation, you can put the value of dx and u, and you'll see that everything cancels out and it's a very sweet term left at the end, which is u du, the integration of which would be u square by 2, and we'll put back the old values. So I guess they have put 2 there to make our life easy. This 2 could be inside or outside, it does not matter. The second question is question number J, which is integration by parts. I'm taking an image from Wikipedia. It's the same as the formula sheet. So generally I would take x as u because I want to get rid out of the two functions of x that are multiplied with each other. So when I take x as u and I integrate that, I'll get rid out of x and I'll just have e to the power something which is easy to integrate. So I'm taking ux as x. For this equation I'm taking v prime x as e to the power 2x, and if this is v prime x, then vx would become the integration of this, which is e to the power 2x by 2, and I have all the 4 terms that I would like to have with me. So in the exam, when you start with probably to reduce the chances of error, you can jot down this formula from the formula sheet and calculate u, du, v and v prime and so on. Just remember that this term is the integration of v prime. So the first term is not e to the power 2x, but the integration of v prime x. So I have found out vx and ux, which I'll put at the first term, and then the second term would be vx is into u prime x. So I just calculated u prime x as 1 because that's the reason why I could do that, and I get the answer. So you have to integrate again. So there are you have to do it 2 times. So first you integrate it to get this, but here it's like 2 times integration of e to the power 2x. So this is how it would look like. Now in the exam, if you are confused, you can in fact differentiate this and get to the answer and check whether it's the same or not. I'll talk that in the next next class. Oh, I forgot a minus sign. In fact, since I forgot the minus sign, I can come back and show you that if we differentiate this and we have the formula of differentiation as keeping this constant and taking the differentiation of this term would get cancelled with the term where we'll differentiate x and keep this as constant. And that's the way which reminded me about the negative sign, because I was trying to differentiate it in mind and I saw that I need a negative sign to cancel that out. So that was the integration by substitution and integration by parts. Now if you closely observe integration by part, most of the question would have a single x sticking over something, because when you take a u prime x, you get rid of this x. So it would never be like x square e to the power 2x or x cube. So in most of the question, if you want to detect whether you have to do this by the integration by parts method, you will have x and something which is out, which is a big function of x. So that way you can detect that. Okay, that was all for this one. I hope this was helpful. Late growth.